Hello and welcome to another thrilling stats warm-up. All right, so what we have here is a data table with a couple of different blood measurements that deal with diabetics. And the question asks us to sketch a scatter plot using HbA as the explanatory variable, find the correlation between the two variables, and then describe the direction, strength, and shape of the relationship. Okay, so again, anytime we're making a graph in this class, you're pretty much always going to stat edit. I've taken the liberty of typing in all of the X and Y values. Notice that this is just telling you the subject number. This wouldn't be in any part of your data. You would just be using these two columns and these two columns. So I've got it all in there. I can go to second Y equals, which brings up my stat plots. I want to make sure that I have one stat plot on. All right, scatter plot is the first choice, and then just make sure that it's set to L1 and L2. If you're not getting a good picture when you go to the graph, you can always go to zoom 9, and that will give you the stat zoom so that you get a decent picture. Now again, when you're sketching these for me, I don't need them to be exact. I'm just looking for a general picture of what's going on, but I would like you to label the X and the Y axes. So the bottom is HbA and the vertical is the FPG. And at that point, just give me like a good sketch of what's happening here. So I've got 1, 2, 3, 4, 5. So I've got a bunch that are sort of scattered there at the bottom. Then we've got some going off in this direction. We've got one up here. We've got some scattered down in this direction. Then we've got one over here. And then we've got one way out there. All right. So again, it's not perfect. I didn't just go and measure everything, but it gives me a general picture of what's happening. Now, if I want to know the correlation, right, to find the correlation on our calculator, we actually run the regression. And you have to make sure that stat diagnostics are on. So this is the mode, I'm in the mode menu. All right, there's my mode menu. All right, and I'm making sure that stat diagnostics are on. Then if I run the regression, L1, L2, hit calculate. All right, it'll tell me that my correlation, which is just the R, is 0.48. All right, so in terms of the different things that it's asking me to talk about, the direction would be positive, right? It's moving up and to the right. The shape, there's no like obvious curve happening with the data here, so we can just say that it's linear. All right, obviously it's not like a super strong linear relationship, but it is generally kind of going in this linear fashion. And the strength, all right, it's not very strong. It's not super weak. I mean, we're kind of right in the middle there. So, you know, moderately strong. Again, and this one, you've got the number, so the number is really telling me the strength. But you could put something like, you know, moderately strong. All right. All right. Number 2, the last two observations could be considered outliers. So that would be these two right here. All right, so we've got the one that's way up here at 359. And then we have the one that's way out horizontally at 19.3. Right? The first one is an outlier in the y direction, right? The one that's really high. The second one is the outlier in the x direction, the one that's way out to the right. What do you think would happen to the correlation when you remove the first outlier? All right, so again, I'm going to label these so that we're clear on which one is the first one. and this is the second one. All right. So what would happen when we remove the first outlier? Now, generally, you just want to see, is the point going with or against the overall trend? So if we think of the overall trend sort of as this, we can see that this is going against the trend. It's way higher than a lot of the other observations. So removing the first outlier should strengthen the correlation. Because it goes against the pattern. So by removing a piece of evidence that goes against the pattern, our pattern becomes stronger because that one thing that was going against it is now gone. All right. Removing the second outlier is removing evidence of the pattern. All right. The second outlier follows the pattern. So if we get rid of that, it weakens the evidence for our pattern. All right, we just took away a point that was supporting the pattern, so that's going to weaken our correlation. All right, so removing the second outlier should weaken the correlation, and for the exact opposite reason, because it goes with the pattern. All right. Now, which of these two is going to have a larger impact on the correlation? All right. Remember, the correlation is found by averaging together all of the zx's times zy's. So turning this point into a zx and a zy and taking the product of those two values. Turning this point into a zx, zy, taking the product of those values. Turning this point into a zx, zy, taking the product of those values, and so on and so forth. You do all of those products, and then you average them together. So which one's going to have a larger impact? All right. The second outlier will have a larger impact because it's at the edge of the distribution implying a large zx and zy. All right, and if both of those are large, the product is going to be even larger, which means it's going to have a big impact on that overall average. Here, yes, this one might have a large zy, but it has a much smaller zx, and that sort of counterbalances it. So it's going to have a smaller impact on the average than one out here that has both a large zx and a zy. Okay? So the second outlier, this one out here, is going to have a larger impact because it's at the edge of the distribution, which implies that the zx and the zy are both going to be larger. All right. So let's take a look at the back. This is getting into the actual regression equations. All right, the figure below illustrates data gathered on the relationship between temperature and fuel consumption. The equation of the least squares regression lines is as follows. So identify the slope and what it means in this setting. So again, identifying the slope, that's the easy part. It's just negative 19.87, right? It's the number with the x. The question is, what does it mean? What's the real world implication of that, right? What insight are we gathering from this equation? And it's, for this one, it's a pretty obvious insight, is that as temperatures increase, fuel consumption is decreasing. And specifically, all right, 1 degree works out to be a 19.87 drop in fuel consumption. All right, so that's kind of the mathematical side of it. Plus 1 degree is a 19.87 drop in fuel consumption. The real world implication is just, hey, as temperature increases, fuel consumption decreases, which makes sense. As the temperature increases, people don't heat their house, so their fuel consumption drops. All right, identify the y-intercept of this line. All right, again, that part's easy, 1425. All right, which would be the predicted fuel consumption when temperatures hit 0. Now it says, why would it be risky to use this value as a prediction? All right. We don't have data on X values that low, so our model might not be valid at that range or in that range. All right, and the fancy word from that, from last notes, is extrapolation. All right, trying to use our equation for a value that small would be extrapolation because we don't have data that goes down to 0 degrees. So it might be that fuel consumption jumps way up as temperatures continue to drop, but we wouldn't know that because we don't actually have data on it. And our line might give us a poor estimate because the relationship shifts and we haven't detected that yet. All right, now the last two are just doing some basic sort of plug-in calculation type stuff. Use the regression line to predict the amount of gas that will be used in a month where the average temperature is 30 degrees. Okay, so again, y hat is your predicted value, so it would just be 1425 minus 19.87 times 30. Again, and that's just at that point, basically calculator work. 1425 minus 19.87 times 30, and you get 828.9. So y hat equals 828.9, and that's in cubic feet. All right, but that's our gas consumption. And then if you know that a person used 700 cubic feet of gas, what is your best guess for the average temperature that month? Again, it's just really kind of basic algebra here. So this time the 700 is going in for the y hat, 1425 minus 19.87x. And then you're just going through and sort of doing the calculations at that point. All right, so again, you can just do it all on a calculator. I don't need to see you showing work for an equation like this. You've just got 700 minus the 1425, all right, divided by the negative 19.87, and it's going to work out to be x equals, we'll call this 36.49 degrees. All right, so that would be the average temperature. All right, so none of those are very difficult, but you should be able to do them. So we're just practicing it once or twice here. All right, I hope this was helpful. And as always, if you have any questions, just let me know. Have a good one.